Drone pollution, analyzing and visualizing pollution on campus. Air pollution is a global issue that affects not only humans, but all living beings, because the air breathed is becoming more toxic and hazardous each day. Air pollution is recognized as an international problem by the United Nations, as considered to be one of the causes of cancer, and by the World Health Organization. Considering the importance and worldwide recognition of the issue, we found involvement in prototyping a new pollution monitoring system to be thrilling. The main aim of this project is to develop an alternative, cheap and easy-to-use prototype of the data collection system. The prototype should be easily used in heavily urbanized areas and would use state-of-the-art consumer-level technology. Also, project aims to help people understand and analyze the pollution on campus, by providing tools to retrieve, visualize and analyze the collected data, while taking into consideration different environmental factors such as weather conditions and time of day. First, the Android application retrieves sensor IDs and names in the JSON format by sending a GET request to the sensor API. Drone SDK is used within the Android application to communicate with the drone. During the data collection, Smart Citizen Kit is sending measured data to the Smart Citizen Kit server through the Wi-Fi connection. After the data is collected, Android application uploads the GPS location readings to the server via GET request. Before providing the general public with the access to the most recent data, it must be accepted by the administrator. Pollution readings are retrieved from the Smart Citizen server in the JSON format via GET request and are matched against the GPS data sent by Android. After the data is accepted by the administrator, it can be queried by the public RESTful API. The graphical user interface retrieves pollution data in JSON format by sending a GET request to the public RESTful API. The data was collected with Smart Citizen Kit and AR Parrot drone. The AR Parrot drone was programmed to fly up and down, while hovering at the points of interest. The Smart Citizen Kit was attached to the drone and provided measurements for nitrogen dioxide, carbon monoxide, temperature and humidity. To minimize possible human error, GPS reading collection and drone was controlled and performed by the Android app at the latitude and longitude the drone and phone was located. To simplify the data collection process, one-button solution was introduced, where administrator is only required to place the drone at the point of interest and click one button to perform the data collection. Unfortunately, no data collection was performed, because regulations prohibit to fly the small unmanned aircraft in close proximity to people and buildings without a special permit from Civil Aviation Authority. To manage the data, an administrator panel was created. An administrator is required to log into the system by providing the username and the password. An administrator panel supports multiple sensor management, where additional sensors can be added to the database and old sensors removed. Also, an administrator panel provides an option to preview the data to verify its validity. System automatically detects potentially invalid readings, and highlights both incorrect values in the reading and the reading itself. An administrator has an option to remove any readings, before providing general public with the access to collected data. The public RESTful API allows developers to retrieve from their applications. It provides access to the data through the abstraction layer, which hides the implementation details of the database. Developers can retrieve a JSON-formatted data from any language like Java, JavaScript, PHP, Python, Ruby and others by querying the API with a simple GET request. The API's documentation provides further details on data retrieval. The system provides user interface, which is connected to the public API and visualizes the pollution data on a map. The highly polluted areas are displayed in dark red, whereas areas with light pollution are displayed in light red. The user has the choice to choose between carbon monoxide and nitrogen dioxide pollutants. The areas that are most polluted will be highlighted with a deep red color, whereas the least polluted areas will have a less deep red color. The user has the choice to change the height. This is the height that the data are collected from. He can choose between 0 to 30 meters by moving the slider accordingly. By doing this he can observe that pollution decreases when the altitude increases. If the user wants to observe the data based on various attributes, he can use the advanced menu. In the advanced menu he can change the day of the week, the time of the day, the humidity, the temperature and the aggregation. As data were collected multiple times in each spot and height, the aggregation can give the maximum, minimum and average value of the pollutants for that particular spot and height. The user might want to observe the pollutants values during each day of the week. Which day is the most polluted? Thursday seems the day with the most pollution. The user can also analyze the pollution during specific hours. Is pollution highest during the morning or evening hours? It can be seen that pollution during the morning hours 9 to 11 seems more than 3 to 5. Furthermore, the user can change the humidity and the temperature range. By changing the temperature range, it might be observed that lower the temperature the higher the pollution. He can also choose whether he wants to see the minimum of the values that have been collected, the average or the maximum. What are the maximum, minimum and average nitrogen dioxide emissions? The user can combine any of the attributes height, temperature, humidity, day of the week, time, aggregation to make assumptions of how each one of them affects pollution. An interesting part of the project was how the individual parts, for example database, API, GUI, were connected together to create a system. Also, the project gave us the chance to learn new languages such as PHP, JavaScript and develop an Android app. As a result, we developed a friendly user interface to monitor the damage done by pollutants. The air pollution problem should be recognized, and it's important to keep monitoring pollution and take actions to guarantee a healthy environment for the next generations.